Hello students, we're in Unit 4, we're on Lesson 3, Complex Fractions. We're going to be using our skills from Lessons 1 and 2, so if you haven't watched those videos yet, you might want to go watch those before you watch this one. So a complex fraction is a fraction, but it contains a fraction in the numerator and the denominator also. And you can see two examples here. We're not going to simplify these right here on this slide, but we will be working with these on the next couple slides. So you see we've got one here that has, it has expressions in it. You've got a fraction here, and then this big fraction bar right here, and then another fraction in the denominator. So this whole thing is the numerator, and this whole thing is the denominator, and it's one big fraction. You can see that fraction bar there. Same thing over here. This one just has numbers, 1/2 plus 3/4, and that whole thing is divided by 3/4. So sometimes you have a plus or a minus in the numerator or denominator, and sometimes you don't. So over here, we would treat this a little bit differently than we would this one. This one here, we would have to do this addition before we could do anything else. So let's look at some examples. We're going to look at an example here with the steps to simplify. So I have the steps here. Here's our original problem up here. And the first step says rewrite the problem as a division problem. So this is the numerator, and this is a fraction bar. And you remember fraction bar just means divide. And then this is the denominator. So I just wrote the numerator here as the dividend and divided by, and then the denominator is what we call the divisor. And so I just wrote that out as a division problem. I'm going to keep it as a division problem. I just separated this into two different simplification problems because they both have addition in them. So step 2 says if there's an addition or subtraction problem on either side, do that next. And that was our lesson 2. That was our addition and subtraction of rational expressions. So, and I didn't go through all the steps here, but this 1/4 plus 1 over 4v simplifies to v plus 1 over 4v. And then this one here simplifies to 4 plus v over 4v. Now, the next thing I'm going to do, once I get these, the addition or subtraction done, and I get just a simple fraction here with expressions in it, then I change it to a multiplication problem. And you remember in dividing fractions, we change it to multiplication, and then we flip or we take the reciprocal of the second fraction. So I just brought down the first fraction, changed the division to times, and then I flipped or took the reciprocal of the second fraction here. So this ends up being 4v over 4 plus v. And then I multiply and simplify, which I've kind of highlighted in yellow here. Because what I did was I canceled out the 4v's. There was nothing else I could cancel out, so I just multiplied across here, and got v plus 1 over 4 plus v. So let's work some examples. So here's an example that just has numbers in it. There's no variables in this example, but I thought we would work through one like this first. So let's look at our steps. I've put the steps over here. They're a little bit smaller. Rewrite the problem as a division problem. So first thing we want to do is get rid of this big fraction bar right here by just writing both sides, the numerator and the denominator, as a division problem. So I'm going to write 1/2 plus 3/4 divided by 3/4. Now, step 2 tells me if there is addition or subtraction on either side, do that next. This one has addition, so I need to simplify this. I need to add these two fractions, so I'm still going to leave it a division problem, and I'm still going to have my 3/4 over here because this can't be simplified anymore. 1/2 plus 3/4, I can change this 1/2 to 2/4, and I'm just going to do that right here. So I'm just going to change that to 2/4. 2/4 plus 3/4 is 5/4. So now that I've got just a fraction here and a fraction here, now I can change it to a multiplication problem. And that's what step 3 says. Change to multiplication, flip the second fraction. So bring down the first fraction, change this to multiplication, and that changes to 4/3. I can cancel out my 4's and then just multiply across. That's going to be 5/3. So that's going to be my answer. All right, let's try some more examples with variables in. Okay, so I want you to understand that sometimes step 2 won't be necessary. Only if there's addition or subtraction in the numerator or denominator will you actually do step 2. So in this problem, we won't need to look at step 2. Whoops, thought I had a pen. Let's try that again. There we go. So we won't need step 2 in this problem. What we're going to do is rewrite this as a division problem. N over 2 divided by n squared over 4. And then we're going to change it to multiplication. Bring down the first fraction, change this to multiplication. And then we're going to multiply and simplify. We want to simplify first because we can cancel out some stuff before we actually multiply this stuff. So let's divide the n and the n squared. Remember, you can cross cancel these. Let's divide the n and the n squared by n. N divided by n is 1. N squared divided by n is n. Let's divide these by 2. That's going to be a 1 and a 2. And so when we multiply across, 1 times 2 and 1 times n, our answer is 2 over n. So to determine whether or not we're going to use step 2, what we're looking for is a plus or minus between two fractions in the numerator or in the denominator. I have a minus symbol here, but that's all in that numerator of this smaller fraction here. So if I don't have a plus or a minus and then another fraction over here, I'm not going to use step 2. So I'm going to mark it out again. I don't need it. Okay, and you don't have to mark that out. You can look and see after you've rewritten it. So rewrite as a division problem. B minus 1 over b divided by b squared minus 1 over b squared. So the next thing I'm going to do is I'm going to go ahead and write this as a multiplication problem. So I'm going to bring down the first fraction. It gets written exactly like it is. This gets changed to times. And then this one gets changed to its reciprocal. Now, as I'm writing this, I could go ahead and factor this numerator as the denominator here. This is a difference of 2 squares, so I could go ahead and write this as b plus 1 times b minus 1. If you want to do the extra step and write it like this first, and then in the next line do that, you can. But if you're used to doing the division and multiplication, then you can factor as you go. That was the only thing I could factor. Everything else was already factored. So the only thing, I can cancel out the b minus 1s. I can also cancel the b and the b squared. Divide those by b. So let's see. This is a 1. The numerator is going to be b, and the denominator is going to be b plus 1. Now, I'm not reviewing a lot of multiplication and simplification here because I did those in lesson 1 and 2. I tried to cut it off, but you might have seen that one already. In this problem, there is a denominator that just has one expression in it, and I'm going to put that over, if I can get a pen, over 1, because I know I'm going to be flipping that over in a little bit, and I'm going to need that. So that goes over 1. And then I'm going to follow my steps. So let's rewrite this as a division problem. All right, so yes, we have subtraction symbols in these fractions, but we don't have a fraction added to a fraction or a fraction minus a fraction. So now we can skip part 2 and change it to multiplication. So I've done that, and my multiplication and simplification process was in lesson 1, and that said you got to factor stuff before you can do anything else. So I'm going to factor the 15 minus 15y. I'm going to take out a GCF of 15. Can't factor this denominator in any way. And then I'm going to factor this denominator and take out a 12. So let's see what we can cancel. I can cancel this 15 and this 15. And then I think that's it. I see a 1 minus y and a y minus 1. And if you remember from the last lesson, we talked about this. If you've got addition and these are switched, you just cancel them out. But if you have subtraction and you have two of the same terms but they're switched, so I've got the 1 minus y and down here I've got the y minus 1, this whole thing right here just equals -1. And I explained in the last lesson why that works that way. So I can mark these out, and as long as I put a -1 in the numerator, I'm good. So it equals -1. All right, so then my answer ends up being -1 over 12y squared. So I'm pretty sure this next problem was on the original steps, or on the original examples page, which was the second slide we looked at. So what we're going to do here first is rewrite this as a division problem. Okay, so I rewrote it as a division problem. I do notice my students sometimes trying to rewrite it as a multiplication problem and flipping this denominator. That's okay if you do that as long as you keep that straight. I do this first because I just want to make sure I get everything in the right place. Okay, so now I'm going to rewrite it as a multiplication problem. There is no fraction added to a fraction anywhere, so I can leave out part 2. So I'm going to change it to a multiplication problem, and I'm going to flip the second fraction over. Okay, so you see that's what I did. I changed this to multiplication and flipped the second fraction, made its reciprocal, changed it to its reciprocal. So if you're kind of good at keeping all this stuff together and keeping it straight, you could go ahead and factor these trinomials as you go. I like to just rewrite everything, just so I can keep everything in the right place. So I would encourage you to pause your video, rewrite these two fractions, and see if you can factor this trinomial and this trinomial. Both of them have an a value of 1, so they're pretty easy to factor. So this is what it should look like after you factor the two trinomials. I see a b plus 2 and a b plus 2. I can cancel in this numerator and denominator. And remember, you can cross cancel just as long as one of the factors is in the numerator and one of the factors is in a denominator. So I can cancel out the b plus 4 as well. I've canceled out everything in the denominator except a 1, so I really don't need a denominator of 1. My answer is going to just be, it's b minus 5 over 1, which is just b minus 5. So my next example has addition and subtraction of fractions and whole numbers in both the numerator and denominator. So I will be using step 2 on this one. First thing I want to do is rewrite this as a division problem. So I'm going to pause my video and I'll come back with it rewritten as a division problem. I rewrote it with the ones as fractions, 1 over 1. You don't have to do that, but I think it kind of makes it easier to look at it as an addition and subtraction problem. Okay, so what I do is I didn't write my division here, sorry. Divided by. I put a line here because we're going to treat this as two separate problems until we get a simplified fraction on each side, and then we'll come down here and change it to multiplication. So I need to look at just the left side first, and I have 1 over 1 minus 7 over x plus 1. Without going into a lot of detail, we did this in lesson 2. We did adding and subtracting rational expressions. The LCD here, or least common denominator, is x plus 1. So that means I need to multiply over here numerator and denominator. That gives me x plus 1 over x plus 1, which still equals 1. And then I'm subtracting 7 over x plus 1. So x, nothing I can combine that with, but the 1 and the negative 7, I can change that to plus negative 7. The 1 and the negative 7 is minus 6, so this is x minus 6 over x plus 1. Okay, over here, I have a common denominator again of x plus 1. So I'm going to multiply this side over here. I don't need to multiply by 1 over here because that would just give me the exact same thing anyway. So then I have 4 over x plus 1 plus x plus 1 over x plus 1. The 4 and the 1 can combine. So I'm still division here. Now I need to change it to multiplication. All right, so x minus 6 over x plus 1 times x plus 1 over x plus 5. My x plus 1s can cancel. And my answer is x minus 6 over x plus 5. So keep these separate until you have a fraction and a fraction. If you have pluses or minuses between two fractions, you need to do that addition or subtraction before you switch this to times, to multiplication. Another trick I can show you for this one is that if your denominators are the same, like this one right here, you can actually mark out those denominators, and then x minus 6 divided by x plus 5 looks like this. So if your denominators are the same, just do the division, just rewrite this as a fraction, and that will work too. Kind of like when we did exponential equations with like bases. You can just mark out the bases and put the exponents equal to each other. You can mark out these denominators and just do the division, x minus 6 divided by x plus 5. Okay, so again, I have fraction plus fraction and fraction minus fraction in the numerator and denominator. So I'm going to rewrite this as a division problem, and then I'm going to work each of those on both sides and then look at what I've got. So I decided to move my steps down here and give myself a little bit more room here so I can work, because my common denominator on both sides is actually going to be x plus 1, x minus 3. So, it's going to be like this, x plus 1, x minus 3, which means this side needs the x minus 3. So I need to multiply times x minus 3 over x minus 3. And then this side over here needs the x plus 1. Now I can leave my denominator in factored form, remember. I'm going to draw a line here too, so I can keep these separated for a minute. Same thing over here. My least common denominator again is x plus 1, x minus 3. This side needs the x plus 1. And this side needs the x minus 3. If you remember back in lesson 2, we color coordinated these and used highlighters and said, oh, this one needs the green and this one needs the yellow. So if you don't remember that, or you haven't watched that video, you might want to go back and watch that. Okay, so this one is going to be, that's going to be x minus 3. And then our common denominator. And then this is 3x plus 3. This side is going to be, we're going to multiply this 2 in. That's going to be 2x plus 2. And then this one's going to be, we're going to change this to plus negative 1. This is going to be negative 1x. We'll just do this. Negative 1x plus 3. Because when we distribute that negative 1 in, we get a plus 3. And then, of course, I think I wrote, oh, that should be a plus. One more step. I'm going to combine like terms here. X plus 3x is 4x. Minus 3 plus 3 is 0, so I don't need that. And then this is divided by 2x minus 1x is x. And then 2 plus 3 plus 5. Same denominator. I just wrote them in a different order, but you can rewrite them the other way around. Now, remember a while ago, I told you if you've got the same denominator, you can mark out those denominators. You don't need to rewrite this as multiplication or anything. This is just 4x divided by x plus 5, and you just write that like this. That's the answer. It can't be simplified. Okay, so again, if you got the same denominator on both sides for a division problem, rational expressions, mark out the denominators, do the division. This divided by this, write it as a fraction, and that's it. Okay, I have 2 more examples for you. So this first one, I'm not going to have a step 2 because there's no fraction added or subtracted from another fraction in the numerator or denominator. I'm going to rewrite this as a division problem, and then I'm going to rewrite it as a multiplication problem. If you want to skip that step, you can. I'm going to pause my video and come back to you. Okay, so I wrote it as a division problem, and what I'm going to do is as I start to write this as a multiplication problem, I'm going to go ahead and start doing some factoring. On this one, I'm going to take out a 2v as a greatest common factor. And then this one on the bottom, I'm going to go ahead and tell you what the factors would be for this one, but you would have to split that middle term to factor this. This would be 2v minus 7 times v plus 1. So just to save some time. Okay, so now I'm multiplying. I need this as the numerator, but I'm going to go ahead and pull out a 10 here. And then I would have, b squared minus 1. That is difference of 2 squares. So I'm going to go ahead and factor that as well. So, and then this one, I can take out a 4. And what I would be left with, I'm just going to write this, I'll write it over here. I would have b squared plus 7v minus 8. So I'm going to go ahead and factor this into 2 binomials. So I took out the 4, I have this left over, and when I factor that into 2 binomials, I have v minus 1 and v plus 8. So at this point, I can start canceling stuff because I've got everything factored. I've got it as a multiplication problem. So I can cancel stuff from numerator and denominator. I can't cancel stuff that's, either both of them are on top or both of them on bottom. But anything that is numerator and denominator, I can cancel. So here's a v plus 1, a v plus 8, a v minus 1. And I can also cancel this 2 and this 4. So I can divide by 2. That leaves me with a 10v in the numerator. Unless I miss, oh no, I take that back. Let's do the 2 and the 10. We can do that also. Divide those by 2. So now we have a v and a 5 in the numerator. So that's 5v. And I believe our denominator is just 2v minus 7. A whole lot easier to look at than this thing right here. Okay, so this is the last one, and I did want to show you that if you choose, you could switch step 2 to step 1. In other words, you've got this this denominator right here, and it has not multiplication, sorry, it has subtraction in it. So it's a fraction minus a fraction. You could go ahead and simplify this first and then rewrite it as a division problem. So we'll do that just for kind of a little change of pace. So what is our least common denominator is 4x. So this side needs a 4. And this side needs the x. So we're multiplying times x there. So that's going to be x cubed over 4x minus 16 over 4x. Okay. So that is x cubed minus 16 over 4x. So what that means is this fraction is now the denominator. So then when I rewrite it, there's my division. Now I can skip step 2 because I already did that part. So then I can rewrite it as multiplication. Okay, the only thing I can cancel out is that 4. Man, I'm looking at this thing thinking there should be a way I can factor this, but there really isn't. If this were x squared minus 16, I could factor it. Still wouldn't make any difference, really. So I just need to multiply across. X squared times x is x cubed. And my denominator is x cubed minus, x cubed minus 16. So I want you to notice, a lot of people are tempted to mark out these x cubes, but this is the factor right here. You can only cancel out entire factors. So if I had another x cubed minus 16 up here, I could cancel it out. But because it's got that minus between it, this is the whole, this is the expression right here. This is the factor. So I can't cancel anything in this. So this is actually the final answer. All right, so that will do it for complex fractions.